Okay, so good afternoon class. Ang ating topic for today, for the entire final period, will be fuels and combustion, and then after this is steam power plant. So this is a part of your final quiz and then your final exam. I think that is halo-halo nung lahat ng tinuro natin about power plant and industrial plant. So just a summary of all the formula. Okay, ginawa ko na ng paraan para matapos natin siya, mai-summarize ko yung lahat ng fundamental formula, values, constants na kailangan nyo pagdating ng fuels and combustion. So, I have here 19, okay, 19 na summarized formula about your fuels and combustion. Pinadali ko na rin dyan yung, yung mga ORSAT analysis, yung air-fuel ratio, daw dulong's formula, ayan, the HHV kapag liquid fuel, yung Bureau of Standards, okay? Tapos kapag solid fuel or the coal analysis, meron kang given, pinadali ko na po dito. Hindi na po kayo maghahanap dahil sapat na yan. Okay? Sa buhay natin, hindi tayo naghahanap kapag sapat ang binibigay sa atin. Okay? So, a little bit of a little bit of refresher lang to. So, alam ko naman kaya kayo nakarating sa point na to on your graduating class kasi napagdaanan nyo na siya. Okay? No need to worry about. So, I have here 14 problems. So, I think every 1, 2, 3, 4 problems, I will take a pause. Or siguro, try ko hanggang 5. Okay? Para mas concise yung ating explanation. Okay? So, let us start with number 1. So, an ideal auto. So, auto cycle tayo. Okay? So, dito sa ating formula, let us take yung auto cycle. Okay? Dito tayo magsimula. Yan. So, before we go to auto, a little bit of refresher, meron tayo dito mga mnemonics na ginawa. Okay? Nung ako nag-review sa board exam, meron kaming mnemonics about this. But let me tell you first yung kanilang brief discussion. Diesel cycle, okay? It is comprised of three processes. Okay? Dalawa yung isentropic. Kasi ito, isentropic, constant S, okay? Constant P, isobaric, constant T, isothermal, constant V, isometric, constant, ano ba yun? Wala pala, yan lang pala yun, iba na. Constant enthalpy, ayun, constant enthalpy. Kapag constant enthalpy, that is throttling process. Okay? So, ito lang naman ang parati dyan, SPTV. Ngayon, dito sa diesel, you have two isentropic processes. One is in compression and then expansion. Another one is constant pressure, heat addition, and then volume. Constant volume, heat rejection. Doon yan tinitignan. Masasanay din kayo dyan, okay? Huwag natin pansinin yung mga nakaimbento sa kanila. Brayton cycle, SPSP. That means you have two isentropic, two constant pressure isobaric. Dun sa anong yun, nagkakaroon ka ng work production. Malalaman nyo yan dun sa graph. Okay? Erickson, wag natin itong pag-usapan. Ito lang ang mahalaga dyan. This one, this one, this one, this. Somehow, pwede rin to i-consider natin yung auto and then dual. Wag na natin pag-usapan iba. A little bit of trivia. Yung Atkinson mo, yan yung ginagamit sa modern gasoline engines. Okay? Ngayon, meron tayong Brayton, sip-sip daw. Tapos, si Rankine, ganun din. Sip-sip din si Rankine. Okay? Si Carnot, sit-sit. That is constant entropy, dalawa. At dalawang constant temperature process, isothermal. Stirling, TV-TV, ibig sabihin, constant temperature mo, dalawa, and then dalawang constant volume. Lenoir, ang nandito, Lenoir ang basa. Huwag natin focus yan. Si Otto, SBSB, sabi-sabi ni Otto. Sip-sip daw si Brayton at si Rankine. Diba? Tapos si Diesel magte-take ng exam. Sure pre, sure ball. Diba? Sure pre, sure ball. Si dual cycle naman, mas mayabang daw kaysa kay Diesel. Sure ball pre, sure ball. Diba? Ibig sabihin, meron kang 5 processes pagdating ng dual cycle. Now, let us focus about auto cycle. Okay? Anyway, the Carnot cycle is the most efficient cycle of all the gas cycles na meron ka or the heat cycles na meron ka. Ayan, the Carnot cycle. So, ano ang pinakamalapit kay tawag dito, Carnot cycle, yun yung Rankine cycle. Kaya nga nagdudugtong ng peripherals. Ano po ba yun? May reheating ka, open heating, regeneration, para mailapit mo yung efficiency niya dun sa pinaka-efficient na cycle, which is Carnot cycle. Now, let us talk about the Otto cycle. No, for your Otto cycle, medyo mahaba yung discussion nito, pero gawin na natin concise. Okay. Sabi dito, meron kang dalawang isentropic. Okay? Yung first isentropic mo from 1 to 2, that is compression. And then yung volume mo, dito, constant volume. Anong ibig sabihin yan? Nag-add ka ng heat, constant heat. Okay? Constant volume, heat addition. Okay? Nasaan ang maximum volume mo? The maximum volume is at 1. Okay? The minimum volume is at 2. The maximum temperature or the maximum combustion temperature is at temperature 3 or the point 3. Okay? And then, after 3 to 4, that will be isentropic expansion. Expansion. Ba't naging expansion? Kasi pupunta ka ulit dun sa initial volume mo. Where 4 to 1 will be constant volume heat reject. Hindi na natin siya i-elaborate pa kasi meron na kayo niyan sa inyong nasa ating combustion na yan. But anyway, dito sa 1 and 2, tsaka sa 4 and 3, in order for you to find the values na hinahanap dyan, commonly ang hinahanap dyan is P2, P2. You have to use Tito Pipito. Tito Pipito, ayan ito yon, this one. Okay? And then, ang pinakamahalaga kasi sa iyong Otto cycle is the compression ratio. Where the compression ratio is the ratio of the maximum volume to your minimum volume. Okay? And that is RK. And RK is equal to 1 plus the clearance divided by clearance, where your clearance is in terms of the percentage of the total volume discharged. Hindi ko na hindi ko na i-elaborate sa inyo. Meron ako niyan sa YouTube. Okay? You can watch it, yung pinaka-detailed example niyan kapag hindi nyo alam yung diskarte. But for your indulgence, I will repeat it. Okay? I-repeat ko yung pinaka-detailed discussion niya para hindi nyo malimutan. Okay. So this is the problem. An Otto cycle engine with 15% clearance, you are given clearance which is 0.15, operates on. So you are given the mass of flow ng gas, intake state at, so this is P1, this is T1. The energy released during combustion is equal to the heat. So you are given a heat. Okay? The heat added, that is 110 kilowatts. Diba? Kilojoule per second For hot air standard with K is equal to 1.32, compute its cycle efficiency. Now, the cycle efficiency of all heat cycles, di ba equal yan sa work net over QA? Or simply, that is equal to 1 minus QR over QA. Yan na yun. Or, in terms of the given RK, okay, given yung kanyang compression ratio pagdating ng Otto cycle, that is equal to 1 minus 1 over RK raised to K minus 1. Where all of these are given. Diba? Yung RK mo, makukuha mo saan? Ayun 1.32. Where RK, sabi dito, nasan yung formula niya? RK is equal to the 1 plus C divided by C. Basic. Okay? So, sir, pwede natin gawin dito, dire-diretso na. Okay? Where RC or RK is equal to 1 plus C over C. O sir, dalawang uri ng solution na gagawin natin. Okay, ito. 1 minus 1 over 1 plus C divided by C raised to K minus 1. Lahat yan given. Okay, pasok natin yung value. E is equal to 1 minus 1 over, okay, so 1 plus the clearance which is 15 divided by 1 point, hindi, 15 din. 0.15 raised to K. Di ba ang given dyan is 1.32 minus 1. So let us solve the value. 1 minus 1 over, okay, kalimutan yung parenthesis. 1.15 kasi 1 plus 0.15 yun na yun. 0.15 raised to 1.32 minus 1, that is 0.32. Kapag mga simpleng detail na kaya naman i-mental math, yun na lang gawin nyo. Huwag nyo na i-detail na ganyan kasi maubusan kayo. Mamaya maubusan kayo niyan. Lalo na pagdating ng dual cycle. So that is equal to 0.47889. Okay? That is the efficiency of the Otto cycle. Ganun lang po mag-solve niyan. Napakadali. Basic na basic. So let us go with problem number 2. Paste uli natin yung formula para hindi natin malimutan. An Otto cycle operates on 0.1 pound per second of air from 13 psia, you are given P1, and T1, 130 degrees Fahrenheit at the beginning of the compression. The beginning of the compression, ito yun, no? Dito ka magko-compress eh. Ayan, no? This is the compression. Okay? The temperature at the end of the combustion, which is the maximum temperature, T3, is 5,000 degrees Fahrenheit. Compression ratio is 5.5. Hot air standard is at 1.3. Determine the efficiency and work produced per cycle. Okay, let us solve. Okay. So, di ba ang efficiency is equal to work net over QA? And that is equal to using yung compression ratio 1 over RK raised to K minus 1. Oh, ganyan lang, kasimple. You are given yung K, may RK ka, then you can solve for E. The efficiency is equal to 1 minus 1 over RK, which is 5.5, raised to K, which is 1.3, minus 1. You can get the efficiency. Okay. So, 1 minus 1 over 5.5 raised to K minus 1, which is 1.3 minus 1, o di 0.3. The answer is, store natin yung value na kay A. Huwag muna kayo mag-round off pagdating yan. Okay? 0.403591748. Oh, store natin tong value na to kay A. Okay? Now, ang hinahanap natin dyan is work net. But we can get QA. Sir, paano natin makuha yung QA? Madali lang yun, my friends. Okay? How will we get QA? Di ba ang QA dito papasok sa 3 to 1? Therefore, at constant ano to? At constant volume heat addition, QA is equal to, ayun, MCB delta T. Ano yung mga involved dito sa delta T mo? Di ba T3 minus T2? Where M is given but CV ang problema mo. CV for air standard, that is equal to 0.171 BTU per pound degree Rankine. Kapag ano po? Kapag English units. Pag SI, that is 0.7186 kilojoule per kilogram degree Kelvin. Okay? Don't forget about that. Then we can say meron tayong QA. We note that QA is equal to MCV T3 minus T2. The problem is, do you have any value for T2? Wala po. But sir, meron tayong RK, meron tayong P1V1. So use natin muna yung hindi natin alam. Let us use si Tito Pipito. Tito Pipito. kick. Okay? Kapag 2 yun nandito, 1 yun nandito, 2 yun nandito, 1 yun nandito. Problema, may T2 ka ba dyan? Wala po. Pero this is equal also to yung inverse ng volume, okay? Maximum volume, yung nasa taas ha, tignan nyo para hindi rin kayo nalilito. Yung notation niyan, yung maximum value. Yung T2, maximum value. P2 is maximum value. Yung V1 is the maximum volume. O kaya inverse yan ng V2. Raised to K minus 1. But is this familiar for you? Diba that is equal to RK? Diba? Ngayon, pwede nating masolve si T2 and P2 gamit yung RK na yun. So, let us solve. T2 over T1 equal to, tignan nyo ito ay nasa loob na yan. V1 and V2 is equal to RK raised to K minus 1. O, pwede rin nating masolve si P2 using this one. Okay? P2 over P1 raised to K minus 1 over K equal to V2, hindi, V1 over V2 raised to K minus 1. Problema dyan, you have a problem here. Diba this is equal to RK? I can delete that. Gawin ko RK to. Sir, pasimplihin mo nga para sa amin para hindi maglo-loan. Pareho sila ng, may nakapansin ba kayo dyan? Pareho sila nito. Pwede may cancel yan. D equal to RK equal to P2 over P1 raised to 1 over K. Pwede lang kadali. Okay? Pwede na yan. As is na yan. So, let us solve for T2. T2 is equal to T1 multiplied to RK raised to K minus 1. So, pwede na. So, T2, T1. T1 is 130 ata yan. Gawin mo dapat yan na absolute. 130 plus 460 degree Rankine multiply to RK 5.5 raised to K minus 1 1.32. Tama ba o 1.3? 1.3. 1.3. 1.3 minus 1. So the value for T2, value for T2, 130 plus 460 times 5.5 raised to 0.3. The answer will be 983. 983.9223 degree Rankine. That is T2. Okay? Problema mo dyan yung P2. Okay, kung talagang mahina ka sa math, dito ka na lang. Mag-resort ka na dito. Okay? P2 hahanapin mo. Ganito lang po yan. Yung RK mo, huwag ka na mag-cancel. Okay? Raised to K minus 1 equal to P2 over P1 raised to K minus 1 over K. Ganito po yan sa simple math Lagyan mo ng loan dito. LN. Tapos lagyan mo ng loan dito. Tapos ito, since this is both power, ibaba mo dito sa tabi ng RK, ng LN, ibaba mo din dito. So, K minus 1, nasa LN, tapos RK. Equal to K minus 1 over K, LN, nung P2 over P1. Pwede na yan. Diyan ka lang magsimula. Ilagay mo na yung value. 1.3 minus 1, LN, RK which is 5.5. Sure ako may makukuha ang value dito. Equal to 1.3 minus 1 over 1.3. LN nung wala kang P2 pero meron kang P1. What is P1? 13 PSIA. Okay na yan. So, ito kunin natin yung value. I-store natin yung value nito kay A. Oh, dito lang pala kukunin natin. Yun na pala P1. Oh, wala, yun lang pala. Efficiency lang pala pinakuha. Tsaka yung work per cycle. Work net. Meron na pala tayong T2. So, kapag tinuloy ko pa to, ganun lang tamang pag-solve ah. So, you don't have to do it all. Okay? So, extra na lang to. So, let us go to yung T2. Okay? QA. In order to solve for work net, anong gagamitin nating formula? O ito, yung efficiency, meron ka. 'Di ba? Work net over QA. Meron kang QA. Therefore, work net is equal to E times QA. Yan. So, ano yung E mo dyan? Ang efficiency is, uh, ayun, i-store ko kay A. So, 0.400, 0.400, 3591748. 3591748. Yung QA mo, oh, yung mass mo, ano yung mass mo dyan? 0.1 pound per second. 0.1 pound in every second. Multiplied to CV, that is 0. 0. Dito. HP. 0.171 BTU per pound degree Rankine. Tapos yung temperature, 5,000 minus, ano yung temperature na nakuha natin? 983.9223. 9223 degree Rankine. Okay. Pwede niya. Cancel natin yung mga same units. Pound, pound, Rankine, Rankine. So, BTU per second lumabas. The answer is, okay, recall natin si A. Yun. Alpha A multiplied to 0.1 times 0.171 times 5,000 minus 983.9223. The answer is 27. Okay, BTU per second yan ha. The answer is 27.94946 BTU in every second. Now, the conversion unit. Pag hindi nyo alam, lagi tayo mag-stick dun sa 42.4. Eh, hindi nyo alam yung 2545 eh. Diba? Hindi nyo alam yun. Kung hindi nyo nare-recall. Oh, dito na tayo pumunta. Multiply mo ng 60 seconds. Tapos, 1 minute. Ilang BTU per minute sa HP? Oh, 1 HP equal to 42.4 BTU per minute. Ganun lang basic yun. Cancel natin yung same unit. Ito. Ano tira? HP. Now, we can solve for ilan yung power niya ng work. 60 divided by 42.4. The answer will be 38. Mm-hmm. The answer is 38.91 HP. Tingnan nga natin kung tama yung naging sagot ko. Parang may nalimutan akong pindutin. Mm-hmm. BTU per second. Okay. Ano ba yung efficiency? 0.4003591. Then, nasa A na yan. Alpha A times QA. 0.1 times 0.171. 0.171. CV of R eh. Diba? The CV of air. Check natin dito. CV of air is, nagduda tuloy ako. Ayun, CV of air, 0.1714. Dagdag natin. 5,000. Okay? 5K minus 983.9223. The answer will be 27 times 60 divided by 42.4. The answer will be 38.99. 40 nga. Tama yung sagot natin. Okay? The answer is 38.91. Tama lang yan. So, number 3. In an air standard diesel cycle. So, let us talk about diesel cycle. Kunin natin si diesel. Ayun. Diesel. Sir, si diesel po, na-invento yan ni Vin Diesel. Loko, hindi. Hindi po. Hindi si diesel. Hindi Vin Diesel yan, ha. So, ganito na lang po yung kanyang pagpapaliwanag ko. So, from 1 to 2, isentropic compression. 2 to 3, that is constant pressure heat addition. Okay, nandito yan. Constant pressure heat addition. 3 to 4, that is expansion of the gas. Partial expansion. Okay, hindi na equal yung volume ni 3 kay 2. Unlike nung auto, equal yung dalawa. So, meron ka diyang compression ratio and syempre, the clearance. Okay? Clearance ba yan? Yan ang tawag ata doon, clearance ratio. Hindi ang compression ratio eh. Ito ang compression ratio. This is clearance ratio ata ang tawag. Kalimutan ko tuloy. Basta yun, clearance ratio. Clearance ba talaga yun? Parang clearance ratio. Tapos yung isa sa dual, expansion ratio. Tama. So, dito, tandaan nyo pag para makabisado nyo, efficiency niya, may isang auto, i-multiply mo kay RC minus 1 over RC minus 1. Ang problema dito sa taas, kapag yung nasa taas siya, yung K nasa taas, pag nasa baba yung K din. Okay? Ulitin natin. Yung efficiency daw ng cycle niya sa diesel. Meron tayong auto. Ano ba yung auto? 1 minus RK raised to K minus 1. Multiply 2. Sa taas muna para hindi ka nalilito. RC minus 1. Tapos RC minus 1. Ang problema, kapag nasa taas daw, meron nasa taas na K. Pag nasa baba, di nasa baba din yung K. Sabi niya. Okay? Yun lang po siya. So, let us solve this problem. Okay, another one, okay? Sa diesel cycle, for the entire discussion po niyan, you may check the YouTube channel. Nandun yung kanyang pinaka-detailed and elaborate explanation. So, in an air standard diesel cycle, tignan ko yung question. Yeah. For an air standard diesel cycle, compression starts at 1,000 kPa. So, you have P1 here. And then, T1. The compression ratio is 16 to 1. Pag sinabing 16 to 1, that is RK, that in every tawag dito, in every one part of the volume, meron kang 16. 16 times na ikinompress siya. Ay, ganun yun. 16 to 1, that is the ratio ng volume. Paano mo ilalagay yan? Dito kayo nalito, that is 16 over 1. Or yung RK mo is simply 16. Yan lang po. Yun ang ibig sabihin ng 16 to 1. 16 to 1, 7 to 1, 10 to 1, 15 to 1, and so on. Okay? Huwag kayong malilito doon. The maximum temperature. Always, the maximum temperature of your combustion is where yung naging dulo ng iyong heat addition, and that is at 0.3. Okay? That is the maximum temperature. Maximum temperature and maximum pressure. Pareho lang yun ng combustion. Pero it is always at 3. Okay? Now, determine the cycle efficiency. Okay, for the cycle efficiency, ito na siya, given na. Okay, meron kang RK, meron kang RC, wala. Meron ba RC dyan? Binigay ba niya? Wala kang RC dyan, ang problema mo. Okay? Hanapin mo si V3 and V2. Okay? Hanapin mo muna si V3 and V2. Ang problema mo dyan, si V3 at V2, ayun o, nandito. Kasi, at 0.223, that is constant pressure. Going back to your, at 2 to 3, that is, ang iyong process is constant pressure, where pressure is the same. Okay? And that is, diba, from PV equal to PBT equal to PBT. Okay? Constant daw pressure, cancel mo to, cancel mo to. Lagyan mo ng notation, this is 2, this is 2, this is 3, this is 3. Pagsamahin mo, okay? Yung mataas na volume, ano ba yung mas mataas na volume? Siyempre yung V3. V3 over V2 is equal to T3 over T2. Diba? Meron ka bang T3? Yes. Meron kang T2? Wala. So, this is equal to RC. Pwede mo masolve si RC using this one. Okay. Therefore, RC, hanapin mo natin si R2, T2. Okay. Gagamit ka ulit ng at 0.122, that is T2 pipito. Okay. That is P 2 over P1. Okay. T2 over T1 raised to K minus 1 over K. Ang problema, hindi binigay si P2. So, solve mo pa rin yan. Pero, meron kang binigay na RK dyan. Di ba equal sa RK yan? Lahat ng yan. Raised to K minus 1. O, ito na lang gamitin natin para mahanap si T2. Therefore, T2 is equal to dito, RK, T1, multiply to RK, raised to K minus 1. O, yung T1 mo, absolute dapat yan. I think that is 300K. Yun, 300K. 300 Kelvin. Multiplied to RK, which is 16 to 1 o di 16. Raised to K minus 1. Ano ba sinabi dyan? O, wala sinabi. Therefore, air standard. Air standard. Pag sinabing air standard, hindi at hot air standard Therefore, that is 1.4. Pag sinabing hot air standard, that is 1.3. Okay? That is 1.4 minus 1. Then we can say T2 is equal to 300 times 16 raised to 0.4. Yun. So, that is 909. 909.42994 degree Kelvin. Okay? Now, we can solve for RC. RC is equal to maximum temperature divided by T2. Oh. Maximum temperature. Ano ba yung maximum dyan? 2031. Okay? 2031 degree Kelvin divided by 909.42994 degree Kelvin. Now, kapag compression, hindi compression yan clearance ratio. Okay. Store natin itong value kay at is 2031 divided by alpha A. The answer is 2.233. 2.2333. Ano yung clearance ratio? Now, sabi mo, sa diesel cycle, sir, yung efficiency, that is equal to isang auto multiplied kay RC minus 1 over RC minus 1. Ikulong mo yung nasa baba. Okay? Kapag yung nasa taas, o di yung K mo nasa taas. Kapag nasa baba din yung K. Okay? So, let us solve. 1 minus the compression ratio is 16 raised to 1.4 minus 1 multiplied to RC. RC is 2.2333 raised to 1.4 minus 1 over RC. RC is 2.2333 minus 1 multiplied to 1.4. Multiply mo lahat yan ng 100%. Now, we can get the answer. Store natin to. Okay? Sir, may convenient ba na way para isolve siya? Yes, there is. Okay, tignan nyo ito ah. Isolve mo muna yung, hiwalayin mo sila. Okay? You let this as A, part A, and then part B. Unahin mo parati si part A. Okay. So, that is 1 minus 1 over RC. Ano yung RC dyan? RK pala. 16 raised to 1.4 minus 1. O, store mo to kay B. Kasi meron nakastore kay A eh. Tapos to store mo kay C. So, RC. O, di recall mo si A raised to 1.4 minus 1. Tapos, recall mo ulit si A minus 1. Huwag mo kalimutan yung parenthesis times 1.4. Tapos, store mo to kay C. O, ngayon, meron ka ng value ni B at C. O, di alpha B, alpha C na lang. The answer is nangyari. Kung nagkamali. 2.1 minus 1 over 16. Okay. 0.4. Store natin to kay A. Tapos, RC ay 2.2333 raised to 1.4 minus 1. Ayun, dito pala. Hindi ko na ibaba. Tapos, 2.2333 minus 1 times 1.4. Shift, store B. Okay, recall A times recall B. 80 nga. Nangyari. 80%. What happened? Okay? That is, I don't know what's happening. Tama naman ginagawa ko. That is 0.8072. 1. Okay? Ano yung efficiency? Taas naman masyado. Okay, let us take a 5-minute break. After nung problem number 4. So problem number 4, an air standard diesel engine using hot air. Okay, ni-specify na hot air. Ito yung value, 1.33, tapos ang R niya is 0.276. Has a condition of 5,000 kPa at 800 degree Kelvin at the end of compression stroke. So, at the end of the compression stroke daw. So, that is 0.2. Okay? Tignan natin. Ayan, 0.2 yun, compression stroke eh. So, yung end ng compression stroke, start of the compression stroke, end of the expansion, okay? And then the combustion. So, 3. So, meron ka dyang heat supplied, okay? Meron ka ring compression ratio, RK, 16. Ang pinapahanap sa'yo, the cut-off ratio. Ayun, cut-off ratio pala. Hindi pala clearance ratio, cut-off ratio. Cut-off. Naalala ko na. Sorry naman kanina. Hindi pala clearance ratio, cut-off ratio. Medyo nakakalimutan ko na yung mga tawag sa kanila. Pero lahat yan solve ko naman. The cycle efficiency and then the MEP. Ano po ba MEP? That is the optimal pressure where your engine would run. So, MEP is mean effective pressure. That is equal to work net divided by the volume discharged. Volume displaced. Ano ba mga binigay dyan? Okay. So, ang problema natin dito, wala tayong RC. cut off. Meron tayong RK. Wala tayong efficiency ng cycle. And then MEP. Isa-isahin natin. So, ang gagawin natin, isolve muna natin si T3. Okay, T2 meron ka na eh. T3 wala pa. Pero given sa'yo yung QA. Masasolve natin si T3. Di ba ang QA is equal to M CP tapos T3 minus T2. Wala tayong T3. Pero pwede tayong mag-algebra. QA M CP equal to T3 minus T2. Ito ang hinanap natin, T3. Therefore, pwede natin solve si T3. T3 is equal to QA over M CP plus T2. So, T3. Ang QA mo dyan is 2250 kilojoule per kilogram. Ayun yun, no? QA over M. Ito yan, ha? QA over M. Specific heat yan. Specific heat added. Yan. So, yung CP ng air, that is 1. Hindi pala pwede. Okay? Hindi pwede siyang isolve mo ng CP. Kasi ang K mo, okay? Going back, okay? The CP is, saan na yun? Ayan, CP is K, given yung K, and then R. Specific yung R eh. Hindi niya ini-specify na. Air standard, hot air standard daw yan eh. So, K, R over K minus 1. Balik tayo sa 4. That is K, R over K minus 1 plus T2. Okay, solve natin. T3 is equal to 2250 divided by K. Ano yung K natin? 1.33 ang nakalagay. Multiplied to. Ano yung binigay dyan na R? Okay, 0.276. K minus 1 o di 1.33 minus 1. Yun yung nasa baba. Plus T2. What is T2? Binigay dyan. End of combustion. That is 850K. 850 kelvins. So T3 is 2250 divided by 1.33 times 0.276 divided by 1.33 minus 3. Minus 1. Hindi 0.33. Okay. 2022. Nag-iiba ang sagot. 1.33 lang naman binigay. Okay. 2250. Okay. Minus 1. Okay. Nag-add na ba ako dito? Ng 850. Ayan. Plus 850. Equal ko na lang. Plus 850. Ayun. 2872. 2872.7198 degree Kelvin. Now, going back, ang cut-off ratio. Cut-off ratio is equal to V3 divided by V2. And that is equal to T3 divided by T2. 2872.7198 divide by 850 or 850. Divide na lang natin to ng 850 para tuloy-tuloy. The answer is 3.79797. That is the cut-off ratio. And now, we go to the efficiency of the cycle. The efficiency of the cycle, meron na tayong cut-off ratio. That is 1 minus 1 over the auto 16 raised to 1.33 minus 1. Multiply natin. Ayun, napansin ko na yun nandito sa number 3. Okay, balikan natin yung number 3. Ito pala dapat, ayun, okay, dito pala dapat, hindi ko binuo. Okay, let us go back. So, 1 minus 16 raised to 0.4. Ba yan? 1 over 16 raised to 0.4. Okay. Multiply kasi yan eh. Yan. Times natin. Yung RC sa taas, that is 2.233 raised to 1.4 minus 1. Okay. Tapos 2.233 raised to, hindi na pala, minus 1. 1.4 times. Okay, masolve na natin to. The answer is 60. Kaya nagtataka ako ang laki. That is, ayan. Ayaw na naman gumana ng aking mouse. Nagloko na naman siya. Ayan. 60 to 266. Yan, correct na to. And for number 4, okay, ulitin lang natin, ganitong proseso pa rin, para hindi ka nalilito. Yung palang ginagawa, okay, i-correct natin yon. Correct natin. Follow up ko lang dito. So, RC, that is 3.3797 raised to 1.33 minus 1 over 3.3797 minus 1 multiplied to 1.33. O, ganito yan. This will be part A. Okay? Ito lang yan ha. Huwag mo isama yung 1. This is part B. So, ang mangyayari, 1 minus A times B sa efficiency. Ganyan. So, unahin ko muna si letter A. Okay. 1 divided by 16 raised to 0.33. Oh, this is letter A. Yung B, 3.3797 raised to 1.33. Tapos minus 1 mo dyan. Divide by 1.33 times, minus mo na lang ng 1 o di 2.3797. So, that is part B. Okay. So, that is, sundin mo to, 1 minus A and B. Alpha A, alpha B. The answer is 0.4873. 0.4873. Oh, meron ka na niyan. So, ang problema mo na lang is yung work net dun sa MEP. MEP is equal to work net over QA. Work net over QA. Work net over VD. But VD kasi, problema ka pa rin. Yan. Yung work net over VD, di ba ang volume discharge, work net, equal to, yung volume discharge mo kasi is the maximum volume minus the initial volume, the minimum volume. Ayan max volume minus minimum volume. Yan. Maximum, minimum. Itong dalawa. Ang problema mo diyan, meron ka bang RK? Yes. Coming from RK, that is equal to V1 over V2. Meron bang binigay sa'yong V1? Yun ang problema mo. Wala kang V1. Pero, meron kang point sa 2. Meron kang temperature sa 2, meron kang pressure sa 2. Okay? Pressure, temperature. Okay. So, if you have pressure and temperature, you can solve for the, oh, di ba? You can solve for your volume 2. Okay. Ang problema mo na lang is V1. So, i-reform natin. Yung MEP mo is equal to work net. Saan mo pwedeng makuha yung work net? Okay? Proceed tayo. Ito ang problema natin. Yung work net mo pwede mo makuha dito sa efficiency. Okay? Efficiency times QA. That is equal to work net. Tapos, yung V1 mo, that is equal to RK times V2. And your V2 kasi, di ba, makukuha mo yan saan? Tignan mo itong equation na to. Okay? PV is equal to MRT. Okay? Yan ang problema mo dyan. Sa PV-MRT, meron kang P, meron kang R, meron kang T. Okay? Specific volume ang makukuha mo. So, ibig sabihin, V1 over M is equal to RK multiplied to what? M, hindi na pala. Kailangan. RT over P. Yan. RT over P. Ganyan na po yun. Specific volume na lang. Okay? So, pwede nating masolve yung MEP. Dire-diretsoin na natin. MEP is equal to E times QA. E times QA over V1. Wala tayo, di ba? So, that is RK multiplied to RT over P. Ano yun? Minus V1 yan, ha? Yung V2. Diba ang V2, masosolve mo pa rin naman sa, let's go back. Yung V2 mo is equal to V2 over M, specific volume, R T2 over P2. Nandito, yung T2 tsaka P2, multiplied to R T2 over P2. Okay, pwede natin factor out, diba? That is E times QA divided by RK minus 1 multiplied to itong buo. R T2 over P2. Very basic. Okay? MEP. We can solve. So, E. What is the efficiency? I think that is 0.4873 multiplied to QA. Ang QA mo dyan is specific din. What is the specific dyan? 2,250. 2250 kilojoule per kilogram. And then, RK, that is 16. Kung di ako nagkakamali. Yun, 16. 16 minus 1. Multiplied to R, that is 0.276 kilojoule per kilogram degree Kelvin. Tapos T2, I think that is 850K. Divided by P2. Ano yung P2 mo dyan? 5,000 kPa. 5,000 kilonewton per meter squared. Okay. So, cancel natin yung same units. Ito, kilonewton meter. Okay? That is Kelvin, Kelvin, kilogram, kilogram. Okay, meter. Kilonewton, kilojoule. Per kilogram to per kilogram. Okay? MEP. Ito na lang matitira. Kilojoule, kilojoule, kilonewton per meter squared, yakit mo dis taas. O, di ba? Pressure siya. That is kPa. O, di, masasolve na natin si MEP. 0.4873 times 2250 divide by 15 times 0.276 times 850 divided by 5,000. Now, the answer will be 1,557 ang kanyang MEP. Okay? That is very basic. 1557.86 kilonewton per meter squared or kPa. Okay? And let us take a 5-minute break.